Hello everyone, this is V. Manikyala Rao, working as assistant professor in the Department of CSE and ML in BVRIT in Asapur. So now today we want to discuss about the other classification methods used in the given data mining, that is genetic algorithm and offset approach. So coming to first one, what is genetic algorithm? Mainly the motive for the genetic algorithm is it is used to identify the best hypothesis value for the given variables. And here we are having collection of genes is called as chromosomes. Collection of genes, actually we are having three types of things. Genes, collection of genes. Genes means zeros, ones, these all. Combination of zeros and ones, these all are called as chromosomes. The conversion of these things into another one is called as offspring values. That means 0 to 1 or 1 to 0 conversion. Now here we are having four types of operators. Coming to first one, crossover. Crossover means we are converting that random, changing that given value. So in the crossover we are having three types of things. First one is one point or single point. So for example, I taken these are the chromosomes. We are call it as chromosome 1, chromosome 2. So when we are drawing the line means after the line whatever the values are there, those two values will be interchanged. So that means 5, 6, 7, 8, 9 will be moved into second value and 3, 5, 7, 5, 8 will be moved into the first value. That is 1 point crossover after the point. 2 point crossover means within the two lines whatever the values are there, those two values will be interchanged. So that means 4, 2, 3 will be moved into first one and 3, 4, 5 will be moved into second one. That is the second one, 2 point crossover. Third one is uniform crossover. Uniform crossover means continuously one after the other, another the values will be changed. So see here, first one 0, 5 will be changed, next one 1, 8 will be there, next third one 9, 2 will be there continuously. Either the values will be changed 0, 1, 0, 2, 4, 6, 8 like that, or 1, 3, 5, 7 like that, the values will be continuously changed. That is uniform crossover. Next one, mutation. Second one, mutation means it is used to change only one point at a time. So here I have chosen 1. So that means that value will be changed into 0. This is called as mutation point. So second one in this, random resetting. So random resetting and is different types. Coming to first one, swap mutation. Swap mutation means the given values will be swapped. So here we are selecting 2 and here we are selecting 6. So those two values will be swapped, 6 and 2. That is swap mutation. Then here 2, 3, 4, 5, 6. Scramble means the values will be arranged on their own. So maybe 3, 6, 4, 2, 5 or 3, 6, 2, 4, 5 or maybe 3, 4, 6, 2, 5. Like that, these values will be changed continue like this within that set. Inverse mutation means the inverse of the reverse of the given number. Here we are taking 2, 3, 4, 5, 6. Then the reverse means 6, 5, 4, 3. Reverse order 6, 5, 4, 3, 2. That is about the third one, inversion. Next one, third operator in genetic algorithm means fitness. So fitness means the fitness value is f of xi. This is a given value in the example. In the given example, the given value, based on that values, we have to calculate this fitness value divided by sum of all the fitness values. That is called as selection operation in the given fitness values. So now I have taken one example, you will understand what happened with these operators. So these are the steps we are performing in this. First one, we have to select the encoding type. Encoding type means the given numbers. For example, they are given the numbers means that will be converted into zeros, binary number format. Then we have to choose any populations. That means, for example, if they are given 0 to 20 means within that range, how many values we need to take, that is population size. Randomly choose the population. So for example, I chosen population size 4 means on what 4 values we are taken out from 0 to 20 range. Then select the parental chromosomes. That means that 4 values is converted into the given binary numbers. Then we have to implement crossover and mutation. Finally, evaluate the final string and then we have to do the same process. Now I have taken the example, you will understand. First one, encoding technique. Let us assume that they are given the function value is x square where the x value range between 0 to 31. So they are given 0 and 31. Actually, these values were converting 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. That means 16 plus 8 plus 4 plus 2 plus 1. So that value is 31. So here how many number of values are there? The same value count we need to take in the first range. So here 5 values are there, that's why we are taking 5 zeros. That is the encoding. Then out of this 0 to 31, we are taking the population size as 4. So based on that, I have to, third step is we need to select the 4 values. So that 4 values are taken as 13, 24, 8 and 9. Out of the range is 0 to 31. We will take these 4 values. And then next step is with the population values, whatever the x values are there, this equivalent binary number. So that how we are written 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. That means the values 2 power 0 means 1, 8 plus 4, 12, 12 plus 1, 13. So that values we written, then we have to calculate the f of x. F of x they are given, f of x is equal to x square. That means 13 square, 24 square, 8 square and 16 square, 19 square. Then the sum of these all the values, that is 1170. Next we need to calculate the probability count value. So probability count value, how we are getting, the probability count is equal to 169 divided by total value 1170. Similarly here also 576 divided by 1170. Here 64 divided by 1170. Here 361 divided by 1170. That is your values of the probability count. Next one, expected count. Expected count means 169 divided by average value 293. Next 576 divided by average value 293. Then 64 divided by average value 293. Then 361 divided by average value 293. Now here the condition is the given value is greater than 0.5, that is nearly equal to 1. If the value is less than 0.5, that is equal to 0. Now see this one here, this value is 0.5, greater than 1 means that value is 1. 1.97 means nearly equal to 2 and 0.22 means less than 0.5, that's value will be 0, and 1.23 means this 0.23 is less than 0.5, that's why the value will be 1. Based on this we need to frame the parental chromosomes. So parental chromosomes, what we have to take, see here the actual count value, third one is 0. So this one is 0. So that's why we have to remove this one. We don't want to take this one. And next step means what we have to do means, in this all 4, this one is having highest value. So that's why what we have to do means, this one is comparable with this one and this one is comparable with this one. So now we will take the second one with 1 and second one with 4. So second one with 1 and second one with 4. Now we have to apply the crossover. See here in the total table, first 2 and 4 will be there, third one will be removed. That's why I taken the 1 crossover. 1 point crossover means 1 will be 0 into 0, 0 will be moved into 1. So 1 point crossover. So this will be moved into this one and this will be moved into this one. The outputs, these are called as offspring values. Similarly third crossover. Why? Because we are already comparing first one and second one, fourth one. Third one is not there. That's why I applied 3 point crossover here. And after that 0, 1, 1 will be moved into 0, 0 and 0, 0 will be moved into 0, 1, 1 like this. These all are offspring values for this. Now, based on those 4 values, that equivalent x value we have to write. That means 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. 8 plus 4, 12. So that value we are written here. Then that value, that x value, f of x means x square. So f of x they are given in the problem is x square. So that value is written. So finally, out of all the f of x values, whatever the value is having the highest value, we need to consider that one and place that particular value. So at the value of 27, we are getting highest fitness value, that is 729. Now we will stop the process. That is called as genetic algorithm. Next one, rough set approach. This is one of the type of classification method. It is used to set the pair of lower and upper approximations. I will show you what is lower approximation and upper approximation. Lower approximation means last one, upper approximation means starting one. So see here, the example, the set of all the objects, that means they are given whatever the attributes they are given, we have to count that attributes. And next one, they have to calculate the indiscriminate relation, that is x comma y belongs to whether those two, a of x is equal to a of y. That means those two values in the rows will be matched, means we will consider that value if we have the values. For example, first one is having 1 2, second row is also having 2 3, third row is having 1 2. If a of x is equal to, consider this one is a of x and this one is a of y. If a of x is equal to a of y means we need to consider that one into our indiscriminate relation, that is a of x and a of y. Then lower approximation means that is belongs to the universe. There is a negation for this one. Upper approximation means the opposite, the last one for this given set. Finally, we have to write the boundary representations. What is the uncertainty rule will be there and the value will be exist in the given set or not. Now I will show you one by one. So these are the different steps are to be there. First, we have to take the information system with objects. That means how many attributes are there and whatever the objects are to be available in the universe. Next, we have to calculate indiscriminate relationship. Next, you need to calculate lower and upper approximations based on the formula belongs to that particular universe or not belongs to the particular universe. You have to find out the decision rules, and finally, you have to reduce that one, and finally, we have to write incomplete data from the given set. Now, I will show you. So these are the steps I have taken. And first step means we have to write the universe of sets. So finally, we are having total 6 sets. That 6 objects are taken as universe. Attributes here we are taking. This is the first attribute and this is second attribute. Temperature and attack, that is your headache, that is your attributes. Decision is they have given the status decision as flu. So now what we have to do means indiscriminate relation. So if x is equal to fa, that a is belongs to a, that we have to write. So now see here, high temperature, the temperature is high and the given attribute headache and the decision flu, we have to take the condition. So these are high and this with s, and next one high with s, 1 and 4 will be there, thus flu will be s. So 1 and 4, that will be written here. Next one, very high temperature with s status, very high temperature is not there, that's why that is only single. Next, high temperature is also only one, high temperature and no headache is only one, so that I written. Next, fifth row, normal, s and no, and then sixth row I written here. And based on that, now we will have to combine the lower approximation and upper approximations. So lower approximations, so objects with flu s means objects with flu s, these two, this one and this one, 4 are this, the 1, 2, 4, 6, they have to be written here. Now out of those all, you need to find out lower approximations. That means the containing since a of x, a bar x is equal to 1 to 4. Why? Because it is belongs to x set. So the given data set is s, s and the given s status. So now we have to write a bar x. So 1, 2, 4 is having the given thing, lower approximations. Now upper approximations means a bar x. So that means now other than 1, 2, 4 is already there. Next things are 3, 5, 6. So 3 is out. Why? Because 3 is having no status. We don't want to consider this one. 5 is also out. 5 is having no status. We don't want to consider. 6 intersects x. So why? Because 6 is having the flu as s. So that's why the 1 to 4 is to be with 6 status will be there here. That is about upper approximation. So approximations means, so to see here, very high s with s status. So that means that is belongs to somewhat alone in x. Now we are combining 1, 2 and 4. Then those two are the lower approximations, starting ones. Upper approximations means next coming ones. So 1 to 4, each 6 will be also status will be same. That's why we are including 1 to 4 and 6. Now we have to calculate BA of x. Boundary region means a bar x minus a bar x. So these values are 1 to 4, 6. 1 to 4, 6 minus 1 to 4. Finally 1 to 4, 1 to 4 will be there, and finally 6 will be there. That is your final boundary region value. So these boundary constraints 6 indicates. So we have to write the decision rules. At the condition, temperature is equal to very high and headache is equal to s. The flu with s contains temperature is equal to very high is to be there in only in s, and s will be there. So object 2. Next, temperature is equal to high and headache is equal to s. So temperature is equal to high, headache is equal to s. Then the flu with s. It contains total object 1 and object 4 is for object 1 and object 4. Boundary object 6 is uncertain. There is no definite rule. Why? Because here it is s, but the headache will be no. Whether it is a positive status, s status means we need to consider and we need to write this one. So these are the rough set approach methods. This is about rough set approach. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.